Mother functions. That's what some people call these. They call them mother functions. Some people call them parent functions. Our textbook calls them common functions. They're all the same idea. But here they are. They're listed out. This is your constant. This is your identity function, because whatever you put in, that's what you get. So you put in a 2, you get a 2. This one is your absolute value function. Here's your square root function, your quadratic, the cubic, the reciprocal function, aka rational function, and then you have the greatest integer function. I like to call this the floor function, because technically it's taking like all these decimals right here in this little interval, like 1.5, 1.3, 1.2. It's taking those numbers and slamming them down to the 1. And so like 1.5 does not go up to 1.5, it goes right back down to 1. It's almost like this function cuts off the decimal, whatever number it is. It just cuts the decimal right off. Like if we had 3.5, okay, it cuts the decimal off and now it's 3. But look at this one, look at this. This is kind of weird. How come like negative 0.5 goes down to negative 1? Oh, so you can't really say that it cuts off the decimal, because that doesn't work for negatives. But if I call this the floor function, or the rounding down function, you're always rounding down to the nearest non-decimal, that works also. Okay, but anyways, we're talking about shifting. So how do things look when you start shifting? Let's talk about this guy right here. If you're shifting this, actually this one is not much shifting. I mean, because like he's related to the slope-intercept form. You guys remember SIF, like y equals mx plus b? All right. There's not much shifting happening with that, like on the problems that you guys are going to be seeing. But there's shifting going on with this guy. How would it look for that? Well, if something is being done to the x, like if we're doing a horizontal shift, there would be an h subtracting from the x inside those absolute value bars. And then if we're going up or down, we would have a k on the outside. Now the h and the k are the most obvious ones to find. Those are shifting. But there's also things you can do to the function to make it change its shape, or you can make it reflect. And so if I wanted to change the shape of this, one thing I could do is I can multiply the x by something. Usually that's represented by an a, and then the k is still chilling out here. Or you can multiply it by something on the outside right here. Let's make this one a b inside. So we got the a multiplying on the outside, the b on the inside multiplying to the x. That's usually what's happening. Now the a and the b, they can be negative. And if you have a negative there, you're going to reflect. Okay, if there's a that's negative, this is now going to go downwards. It's going to look like this. It's going to reflect over the x-axis. If you have a b that's negative, it's going to reflect over the y-axis. Now here, a y-axis reflection won't matter, because it'll just look the same, because there's symmetry about the y-axis. But anyways, let's talk about what the other ones would look like. For this one, if there was an h, it would be with the x inside the square root, like so. Notice that I'm putting a negative here, and that's because whatever the h is, you have to think the opposite. So like if you saw x minus 2, that moves this function to the right 2. And that's true for every one of these. The h, you always have to think the opposite. So this moves to the right, this 2 right here, this h moves this function to the right 2. We can also move it up or down. So we could have a k right here. That would move the function up or down. And then we also have the things we can do to it to change its shape. We can multiply the x by something, and we can multiply the outside by something. And the a and the b would change the shape. It will stretch it. It'll stretch it vertically, or it will compress it. So like, for example, this guy right here, if this was a 2, if a was a 2, this would stretch this guy up. He would go like this instead. So like this point got stretched up. You guys see that? There's a stretch happening right there. All right, so how do these other ones look? This one would have an h inside the squared, so minus h, and then we have a squared, and then we have a b sitting right there multiplying to the x, and we have a k out here. Where would that b go? I guess that b would go inside of this. Let's see. Let's rewrite it. A and then we would have a b right here, and then we would have x minus h. Then square that, then k. The b doesn't happen that often though, but I just wanted to tell you guys it's there. And then so on and so forth. I think the x to the third looks very similar to the squared. You just have to change this 2 to a 3. You have the reciprocal function right here. What would that one look like? That would be x minus h on the bottom. You could have a b down here. Not common though. The a could be out here, but usually what they'll do is they'll put the a on top with that 1, and then you can have a k right here. So it would be like a over b times x minus h plus k. All right, so we got our h, we have our k, we have our a and our b. They transform, they shift our functions.